Good morning, guys. I'm looking at section 6.1, page 318, numbers 1 and 2D. We're starting our exponential functions chapter, and you should have done a couple of investigations on 6.1 by now, and I just want to do this one example with you. So question 1 asks us, which of the following functions are exponential? Explain how you can tell. And in part D, we're given this table of values. And then number 2 asks us for the exponential functions that you identified, write an equation to fit the data. So let's have a look at this table of values first and try to determine whether it's exponential. One of the ways in which we determined what type of function we have given a table of values in the past is to do the first and or second differences if necessary. So the first differences here would be negative 18, negative 6, negative 2, and so on. Obviously, they're not constant. The second differences would be 12, 4, and so on. Obviously, those are also not constant. Therefore, we know that the function is neither linear nor quadratic. So what can we do at this point? Let's just observe the pattern in the y values. So if we look at our y values, 27 and then 9 appears to be divided by 3, then 3 also appears to be divided by 3, then 1 also appears to be divided by 3, and so on. So let's do, instead of doing the first or second differences, or third or fourth or fifth differences, let's do what's called the first ratios. To do the first ratios, we're going to do y2 divided by y1 and so on. So y2 divided by y1 here is 1 over 3 when we reduce it. y3 divided by y2 is 3 over 9, which is also 1 over 3. 1 divided by 3. 1/3 divided by 1, also 1/3. Therefore, the first ratios are constant. And this tells me that the function is exponential. Now, once we know that the function is exponential, to find the equation, we simply use our first ratio as the base, and an exponential function always has a variable as the exponent. So the function would be y equals 1/3 to the exponent x.